Good, Mark. Good. Well, good evening. We're going to get started. So welcome to our Genesis Forum. Tonight, as most of you know, I'm Dr. Richard French. I'm a doctor of medicine. We welcome both our live audience and for viewers online. We appreciate you. Tonight, we have an outstanding speaker, Dr. Jason Lisle. He is an astrophysicist, but he will be discussing the wonders of creation in our solar system. Dr. Lisle is an accomplished scientist who also holds a biblical Christian worldview. He can explain clearly how the evidence of modern science is pointing more and more to the biblical God of creation. Before we begin, we'll make a few announcements. First, we want to thank the E-Free Church for allowing us to meet here tonight, and a special thanks to Mark and Dan for their technical support. Second, a reminder, you should visit the Boneyard Creation Museum at Broken Bow. It has some excellent exhibits for both adults and children, showing strong evidence for biblical creation. The museum has summer hours Tuesday through Saturday, 10 a.m. to 5 p.m. And thirdly, a word about our next speaker. November 3rd will be Dr. Carl Werner. He's the author of a series called Evolution, the Grand Experiment. But he has had extensive studies in the fossil record, which reveal eye-opening findings that expose many flaws in evolutionary theory. About Dr. Jason Lisle, our speaker tonight, he attended Ohio Wesleyan University. He graduated with a double major in physics and astronomy with a minor in mathematics. And then he went to the University of Colorado at Boulder, where he received his master's and PhD degrees in astrophysics. He has done extensive research in astrophysics, including investigations of the dynamics of our special star, the Sun. He's written and collaborated on a number of books, one titled Taking Back Astronomy, another titled The Ultimate Proof of Creation. You can find some posters with some of his books in back tonight. He also wrote a book called Fractals, or How Mathematics is a Universal Language of God and a Secret Code of Creation. This book of fractals has some amazing pictures that relate to mathematical formulas that all point back to the mind of God, putting mathematics and the universe in order under mathematical principles throughout. So, I'm excited to hear Dr. Lisle tonight. First, a word of prayer, then we'll hear from him. So, dear Lord God, we give you thanks for your amazing creation of this universe and your creation of all of life. Thank you for the opportunities you give us to learn more of your creative genius. Thank you for your word, that is your Son Jesus, who put all things together and has redeemed it all with his life, death, and resurrection. So open our minds to better understand your ways and to better serve you. So bless each one hearing this message tonight. Bless our speaker, Dr. Lisle. In Jesus' name we pray. Amen. So, Dr. Lisle.
Well, thank you very much for inviting me to speak to you. It's good to be with you virtually this evening, and I think it's wonderful that we have the technology to be able to do these kinds of things. So this evening I'm going to talk about the worlds of creation, the planets and moons of our solar system, And there's a reason for this. I think it's helpful for Christians to know the basics of astronomy because there's this narrative that if you're a Christian, well, you don't believe in science, right? You're anti-science if you're a Christian. And that is a false narrative. It would certainly come as a shock to the founding fathers of science, most of whom were Christians. They expected to find patterns in nature because God has imposed patterns in nature by his divine power. And they were very successful in pioneering the branches of science, including astronomy. So I think it's helpful to know something about astronomy because that's one of the branches of science that secularists misuse to try and persuade people the Bible's not true. But I want to show you that our solar system is a confirmation of biblical creation. God really did create. He created in 6 days the way he says he did in scripture, and our solar system confirms that. And I think it's wonderful. I'm going to use some technology to actually show you some of these things this evening. I'm using a simulation, but it is based on actual images that we have of these planets and moons. We've sent spacecraft out into space and have pictures of all the planets and many of the moons in our solar system. I think that's wonderful. And what this software does is it takes those images and remaps them so that we can rotate it around. Basically, this will be a very accurate reproduction of what you would see if you were there. This is an overhead view of our solar system, what you're seeing here. And in fact, this is where the planets are right now, in case you were curious about that. And this is the inner four planets, Mercury, Venus, Earth, and Mars. And I have to start here because the fact that our planets orbit the sun and they orbit not in perfect circles. You might notice that Mercury's orbit there is a little bit squashed. The fact that the planets orbit in ellipses rather than circles was discovered by a creationist named Johannes Kepler. And you'll find his name in any astronomy textbook, any introductory astronomy textbook. What you won't find in most secular books is that he was a devout Christian and a biblical creationist. He even computed the age of the earth at about 6,000 years, about the same that we would compute today. And he discovered that the planets orbit not in perfect circles, as was previously believed, but in ellipses, squashed circles. And you might say, well, yeah, I think I can see that with Mercury. I can see it's a little bit squashed. But of course, he didn't have a computer simulation or even drawn out orbits. What he had was a list of numbers recorded by Tycho Brahe, who was also a Christian, from his observatory before the invention of the telescope. You might think, well, what's an observatory for if you don't have telescopes? There were other instruments they used to measure the positions of the stars and planets with very good accuracy. Kepler used those numbers to figure out how planets orbit the sun. And if you think about it, the positions of the other planets are seen from Earth, which is also orbiting the sun. So you basically have to solve two problems at the same time, two math problems simultaneously, Earth's orbit and the orbit of what you're looking at. And I say that just to give you a little bit of a glimpse for how brilliant the man was. And he believed in Jesus Christ. He believed in the creator of the universe. And he also discovered that when planets orbit the sun, there's a relationship between their period and their distance from the sun. Planets that are closer to the sun orbit faster. They make a loop in less time, and their period squared is proportional to their distance cubed. And if you want to use exact numbers, the period in years is proportional to the distance. The period in years squared is proportional to the distance in AUs cubed, where 1 AU is the distance from Earth to the sun. So Earth takes 1 year and it orbits at a distance of 1 AU. So 1 squared equals 1 cubed. That's easy, but it works for the other planets as well. So you see Mercury zipping around the sun there. And Kepler also realized that planets, when they're closer to the sun, they speed up in their orbit. So when Mercury's a little closer, it speeds up. And when it's further away, it slows down a little bit. That's kind of hard to see. It's very easy to see with comets because they have very elliptical orbits. And when they come close to the sun, they just whiplash around and then they travel much slower into deep space. And he discovered the exact mathematical relationship there as well. Now, these are the inner planets of our solar system, the inner four. A lot of people don't realize how much farther away the outer planets are, much further away, and therefore they orbit much, much slower. We really have to speed up time, get the inner planets really whipping around there. Jupiter takes about 12 years to orbit the sun once. Saturn takes 29, and so on and so forth. So it's really amazing to see that. The planets orbit in nearly the same plane. That is, they orbit kind of in the same disk there that you can see. Sometimes you'll see the solar system from a perspective angle like that, and sometimes people think the orbits are really squashed because they think that's an overhead view. It's not. An overhead view shows the orbits are nearly circular, but not quite. Now, what I'm going to do this evening is take you on a little tour of these planets. We'll go back into the inner solar system, and I'm going to reset the time to now. So here's what the planets look like right now. They're all basically on the morning side of Earth, so except Venus. So you might have seen Venus in the western sky, that beautiful, bright, incredibly bright star in our western sky. It's actually a planet. That's Venus. But we're going to start with the sun, which is over 99% the mass of the solar system. The sun is a star, or stars are suns. The sun just happens to be much closer than the other stars, and it looks something like that. It's a ball of hydrogen gas held together by its own gravity. Yes, gas has gravity, and if you have enough of it, it will hold itself together in a spherical shape. And so there's what the sun looks like. It's hot. It's because it's fusing hydrogen in the core. The sun's made of hydrogen and helium, the two lightest elements, trace amounts of other elements. And it's fusing hydrogen into helium in this core, which releases energy, which trickles to the surface and keeps the surface warm. Although I would argue the sun was created with a warm surface. It started that way, but that's what replenishes it over time. And the surface temperature of the sun is about 6,000 degrees Celsius. The core is much hotter. It's about 15 million degrees Celsius, we think, because that's the temperature required for fusion. And the Lord placed the sun at the right distance from the earth so that we could receive the right amount of heat and light. And as Isaac Newton pointed out, that did not happen by chance. That's the result of biblical creation. The darker areas you see on the sun, those are sunspots, and they are cooler regions where magnetic fields have inhibited a bit slower than Earth, and therefore the sun would appear in the sky for weeks at a time, Earth weeks. The night side, on the other hand, because it hasn't seen the sun for a very long time, the night side cools off and is actually very chilly. So Mercury is a planet of extremes, about a third the size of the Earth. One of the interesting things about Mercury that's a bit perplexing to the secularists is that it has a strong magnetic field. And that's always an indication of youth. Whenever you see a magnetic field, it indicates that the planet cannot be billions of years old because magnetic fields decay over time. They're caused by electrical current in the core. Electrical current encounters resistance and decays away. And Mercury in particular, because it's the smallest planet now that Pluto's no longer classified as a planet, but because it's very small, it really can't hold a charge very long. It's just like the little AAA batteries don't last very long. The big D cells, they can last a bit longer. Likewise, a planet that's bigger can keep a magnetic charge longer, but Mercury ought to be magnetically dead if it were really billions of years old. But the Messenger spacecraft and Mariner 10 confirmed that Mercury does indeed have a magnetic field consistent with its biblical age of a few thousand years. And so that's just one of those little facts that you don't tend to hear in the secular narrative. It doesn't fit the secular narrative. Venus is the next planet out. It's been called Earth's sister planet because it's about the same size as the Earth, but that's where the similarity ends. Venus is completely enshrouded in clouds, and that made it very difficult to study for a long time. But the Magellan spacecraft went into orbit around Venus, and it used radar to penetrate those clouds and made a radar map. So we now know the surface of Venus looks like this. It is a barren world. It's got lots of volcanoes on its surface. They're all inactive as far as we know, but nonetheless, it is not a place you want to vacation because the surface temperature is 900 degrees Fahrenheit. It's actually hotter than Mercury because that thick atmosphere, primarily carbon dioxide, traps in heat, and so it's a greenhouse effect, and that makes Venus the hottest planet of the solar system. You might notice also Venus is rotating the opposite of the way Mercury does, opposite the way Earth does. Venus rotates backwards. And that is really perplexing for the secular model of the solar system, which claims that all of the planets formed from a collapsing nebula, which as it collapsed in on itself sped up and everything really, that's why they would say all the planets orbit the same way, which they do. But if they formed from that nebula, they ought to be rotating the same way. And Venus is just exactly the opposite. And I often wonder if the Lord did it that way just to confuse the secularists. But at the very least, it declares his glory, his creativity. So Venus, not a place you want to vacation because it's not got the right atmosphere. That atmospheric pressure alone would crush you. if you didn't boil in the 900 degrees Fahrenheit temperature, or if the clouds of sulfuric acid didn't kill you. So it's not a place to vacation, but God did make it to be beautiful. And you might have noticed it in the western sky just after sunset. It's very, very pretty. So the next planet out is Earth, my very favorite. It's got the best restaurants of any planet. And there you go. So, and what a privilege that we have the opportunity now to see the Earth from above, something that our ancestors could only have imagined. A friend of mine is actually an astronaut, and he's taken all kinds of images of the Earth from above, from space, and it's just beautiful. That beautiful blue from the water on the Earth, which of course is an ingredient for life. We think all life requires water, and Earth's surface is 71% covered with the liquid of life, and I think that's wonderful. Earth rotates at the right rate to keep the day side not too hot, the night side not too cold. It has an atmosphere that distributes the heat around so that the planet can maintain a nice temperature. And Earth is tilted about 23.5 degrees, and that is what causes seasons. And I don't know if you like seasons or not. I rather do. But one of the bonuses of having seasons, having the Earth tilted that way, is it evens out the temperatures a bit and causes the Earth's habitable zones to be larger than they would be if it were not tilted at all. If it weren't tilted, we wouldn't have seasons, but the habitable zones, the places where life could survive, would be less. The equator would be way too hot, the poles would be much colder than they are now, and so on. So the Earth's tilt seems to be optimized for life, and I think that's wonderful. Earth has a number of interesting features. Of course, it's got mountains and valleys. It has not just tectonics, but plate tectonics, where the Earth's crust is divided into plates that, under certain circumstances, can move. And we think that's the mechanism that God used to cause and also to end the worldwide flood. Now, God knew that people would become wicked, and because God is righteous, he knew that he would judge sin at one point by wiping out humanity, except Noah and his family, who found grace in the eyes of the Lord. But the one planet that God knew would have to be flooded at one point, he made it floodable. He designed it with this tectonic structure so that the plates could move, and that would cause the flood and also end it. Dr. John Baumgartner has a wonderful model explaining how that happened. It's a very good scientific model, works very well. So there's Earth with all the right features for life. Liquid water, an atmosphere with nitrogen and free oxygen. That's unusual. Oxygen's pretty abundant in the universe, but having free molecular oxygen, which is what we need to breathe, it's rare. No other planet has that. Earth's the only planet you can breathe on. Earth's the only planet, as far as we know, that has abundant liquid water. And those are design features. The Earth also has a large moon, which we call the moon, because for a long time it was the only one. Until 1610, this was the only known moon. And this is what it looks like from Earth. A lot of people have the impression that the moon doesn't rotate because we always see the same side. But in fact, the moon does rotate. It just rotates at the same rate that it revolves around the Earth. So it keeps the same face pointed at the Earth. But if you were to watch the moon from a distant star, you could watch it rotating as it revolves around the Earth. That's why we always see the same side. So there you can see the Earth in the background as the moon revolves around it. Quite beautiful. And of course, there have been 12 people who have walked on the surface of the moon as of this presentation. Artemis, Artemis 4, we're going to have people go back to the moon and walk on the surface. Hopefully that'll be a tremendous success. I'm looking forward to that. Now, the moon has a number of design features for the Earth. The moon itself, you can't survive there. It doesn't have it doesn't have an atmosphere. You can't breathe. It doesn't have liquid water. It's not designed for life on its surface, but it does stir up Earth's oceans via tides. The moon induces tides on the Earth, and that keeps the Earth's oceans from stagnating. It cleans the shoreline and so on. So it's actually a design feature, and I think that's wonderful. The moon also has what's called remnant magnetism. It has little bits of magnetic field on its surface, and that's an indication that it once had a global magnetic field like the Earth still has, but in 6,000 years, it's decayed away. And so that's an indication that the moon cannot be billions of years old. Likewise, the Earth has a strong magnetic field. That's what causes your compass to work. A lot of people have a compass in their car that tells them the direction that you're going, and that's due to electrical current in Earth's core. And we know the Earth's magnetic field is decaying. We've been able to measure it very precisely for the last century or more. And we know it's decaying. We'd expect that. Current encounters resistance, and we'd expect it to be an exponential decay, which is consistent with the data. And if you run that equation backwards, we find the Earth's magnetic field can't be more than if you run it back 60,000 years, the magnetic field would be too strong for atoms to hold together. So you can't have a millions of years, let alone billions of years old Earth. It doesn't work. A lot of stuff like that you tend not to hear about in the secular world because it goes against the evolutionary narrative. The next planet out is Mars. Now, although Venus has been called Earth's sister planet because it's about the same size, really Mars is the most Earth-like planet. Although it's only half the size of Earth, it has a lot of features in common. It has canyons and valleys and mountains. It has polar ice caps. There's the northern polar ice cap that you see up there at the top. It's tilted about the same as the Earth, so it has seasons similar to the Earth. They just last longer because it's years longer. But and those ice caps, they grow in the winter and they shrink in the summer, just like Earth's ice caps do. Pretty amazing, the similarities. Has a thin atmosphere, thinner than Earth's, but at least it has one. Has interesting features on its surface. Let me rotate around and show you one of the features here. I don't know if you can see the crosshairs here, but there's this large scratch mark kind of in the southern hemisphere of Mars, and that's called Valles Marineris. It is a massive canyon that dwarfs Earth's Grand Canyon. In fact, Valles Marineris is about the same length as the United States. It's not a water canyon, it's a tectonic fissure where the crust has broken apart. So Mars has tectonics. It doesn't have plate tectonics like Earth does, because God knew he wouldn't need to flood Mars. But anyway, although there is evidence that Mars once had water on its surface, and perhaps on rare occasions still does. It has massive mountains. They're volcanic, many of them. You can see three of them kind of right in a row right there, and a fourth really big one up here on the upper left. That large one is called Olympus Mons. It's the largest known volcano. It's 3 times taller than Mount Everest, but it's very shallow sloping, so the base of it would cover the entire state of Iowa. Massive volcano, thought to be extinct, but it might just be dormant. Ron Samek has a neat model where he proposes that volcanoes on Mars are what are responsible for the dried riverbeds that we see, because today you can't have liquid water on Mars because the atmospheric pressure is too thin. Water would, if you take an ice cube and heat it up, it immediately would boil. It would go directly from the solid state to the vapor state because there's not enough atmospheric pressure. But volcanoes can temporarily increase the atmospheric pressure locally to where you can temporarily have liquid water, and that might account for the dried riverbeds that we find on Mars. Mars also has remnant magnetism, like the moon, which indicates it can't be billions of years old. Remnant magnetism, like all magnetism, decays over time and can't last millions of years. Mars has 2 moons, and they're tiny. They're called Phobos and Deimos. Let's go to Deimos first. The names mean fear and terror. Mars is associated with the god of war, and what associates war but fear and terror? So there's Deimos, little moon, and it surprises people. Little moons tend to not be spherical. They tend to have kind of a random shape. I like little Deimos. It's less than 10 miles across, shaped kind of like a potato, which I think is fascinating. And so that's the outer of the 2 moons of Mars. The inner one is Phobos. It's just a little bigger than Deimos. Phobos is a little over 10 miles along its longest length. Again, it has kind of a random shape. So there's Phobos. Orbits very close to Mars, so close that it actually orbits faster than Mars rotates. And so an observer on Mars would see this moon rise in the west and set in the east. It actually beats rotation. The view, if you were to stand on Phobos and look up at Mars, the view would be spectacular because it would take up an enormous part of the sky. One other interesting thing about Phobos is the gravity on this little moon is so weak because it's so small that you could pick up a rock and actually throw it into orbit. So you could actually watch it go over the horizon, and you better duck or it'll come up and hit you in the back of the head. So it's interesting to see these situations that don't occur on Earth, but they can occur out in space. So there's Mars, a wonderful and very interesting planet. We've sent more probes to Mars than any other. We even got a helicopter to fly on Mars, which is amazing. But Mars really isn't designed for life. That thin atmosphere is carbon dioxide, which you cannot breathe. So there's that, and lack of liquid water. Surface temperatures that are often well below freezing. Occasionally they do get up to like 70 degrees, but that's unusual. So there's Mars. Really interesting world. Now, these 4 planets that we've looked at, Mercury, Venus, Earth, and Mars, are called terrestrial, meaning Earth-like. They're like the Earth in the sense that they're solid, they're rocky. Theoretically, you could land on them. We have landed probes on both Venus and Mars, and theoretically, you could walk around on them. But the outer planets are very different. The outer planets, Jupiter and Saturn, for example, are made of gas. So you can't land on Jupiter. There's nothing solid to land on. It's a ball of gas held together by its own gravity, much like the sun. But unlike the sun, it doesn't have enough pressure to initiate fusion of hydrogen in the core. So there's Jupiter, big ball of hydrogen and helium gas, about 10 times the diameter of the Earth. So it's massive. And this is the largest planet in our solar system. And because it's a ball of gas, you get these wonderful cloud formations because different, the hydrogen and helium's pretty well inert, but hydrogen can mix with other elements that are on Jupiter, carbon, oxygen, so on, make elements like methane, ammonia. There's nitrogen on Jupiter as well. And that's what causes those colored belts. Those are clouds basically on Jupiter. Now, clouds on Earth, we have jet streams on Earth and they get disrupted a little bit by the continents, but Jupiter doesn't have any continents because it doesn't have any land. And so the clouds get stretched out into these enormous belts and zones. The belts are dark, the zones are light, just by definition. In the southern hemisphere, there near center, just below center, you see that great red spot, which astronomers call the Great Red Spot, because we're not very creative apparently. That is a massive storm on Jupiter, an enormous anticyclone. It's a high pressure system, like a hurricane on Earth. Now, on Earth, hurricanes, they're powered by ocean temperature. In fact, when a hurricane passes over the ocean, that the ocean temperature drops by 10 degrees after the hurricane has passed. So it's powered by heat. Now, hurricanes on Earth move over the land eventually, and they get cut off from their power source, and they kind of peter out. But Jupiter has no land. And so that hurricane just keeps going and going. And it's been there for, we think, probably at least 300 years. It may have disappeared for a little while in the 1700s. But in any case, you could drop 2 Earths right in that great red spot. That's how big it is. So really amazing. It is shrinking. We don't know if that will continue or if it will stop and reverse. We don't know. It's interesting. Weather patterns on Jupiter are very interesting, but they tend to have a stability that is not found on storms on Earth due to the fact that Earth has land and Jupiter does not. Jupiter has a whopping big magnetic field, so powerful that it causes aurora borealis, northern lights on Jupiter. And that's an indication that Jupiter can't be billions of years old because it has a very powerful magnetic field, much more powerful than the Earth's. Jupiter also has a thin system of rings. A lot of people don't realize that. They think Saturn has rings, which it does, but so does Jupiter. It's just that Jupiter's are very thin, and so they weren't discovered until after the one of the Voyager spacecraft went past Jupiter and turned around and looked at those rings from the backside, which makes them a lot easier to see. Jupiter also has a system of moons, and I was waiting to see, there we go. I was waiting for one of the moons. Occasionally, one of the moons will cross in front of Jupiter and cast its shadow on Jupiter. That's that black spot that you're seeing there. These are fun. You can see these in a modest backyard telescope. And of course, they're predictable thanks to folks like Johannes Kepler and Isaac Newton, who were able to explain why things orbit the way they do. We can calculate when the moons will cast their shadow on Jupiter, and it's fun to watch. It takes about half an hour to an hour for them to cross in front of Jupiter, and really interesting. Jupiter has 115 moons as of today, and it was the first planet discovered to have moons beside the Earth. Galileo in the year 1610 saw 4 little stars lining up next to Jupiter, and as he watched them night after night, he realized they were orbiting around Jupiter. These are the 4 largest moons. The other moons are much smaller and are not easy to see in a backyard telescope, but you can definitely see the big 4 even with a very modest telescope, even the cheap kind you get at Walmart, which I do not recommend, by the way. But even good binoculars will pick out Jupiter's moons. Let's have a look at them now, because we've actually sent spacecraft past these moons and we visited them. And that is not what I wanted to do. Let's try that again. Okay, there's Jupiter. Is it going to do it? It's not going to do it. Oh, got a little malfunction in my code here. That's okay. There's another way to do it. So let's go back. We'll just do it manually here. Okay, let's see if we can get little EO here. Did I get the right one? There we go. That's what it's supposed to do. This is Io. It's the innermost of the big four moons that Galileo discovered in 1610. It's a little bigger than Earth's moon, beautifully colorful. It's hard to imagine a more colorful moon than Io. It's got all of these yellows and oranges and whites, and those are caused by sulfur compounds. If you've ever been to Yellowstone National Park and you've gone to the area where there are these geysers, you'll see similar colors because it's the same chemistry. So it'd have that same awful rotten egg smell. But the other thing about Io that's interesting is it has active volcanoes on its surface. You won't see impact craters, but you do see all these little spots. Those are volcanoes. Io is the most volcanically active world in the solar system, which indicates it has internal heat, and that may indicate that it can't be billions of years old, although it is possible that that heat is generated when Io is stretched between Jupiter and the next moon out, Europa. That's called tidal flexing, and that will generate heat. It's just a question of whether or not it generates enough. But it has volcanoes going off all the time, really amazing. And in fact, when Voyager 2 flew past Io in, I think it was 1980 or thereabouts, it detected 9 volcanoes going off at the same time. So really quite fascinating. So there's the innermost of the big four. The next one out is Europa. So let's go to Europa. Europa is just a little smaller than Earth's moon. It's the smallest of the big four. And it's interesting because it has these large cracks on its surface, these large streak marks, like a big cosmic cat came and just kind of swiped it. And we think those are probably sites of geysers that spew water vapor into a probably a very thin atmosphere of Europa. It doesn't have much of an atmosphere. But that would indicate internal heat. Internal heat is another indication that it can't last billions of years. And Europa is far enough away from Jupiter that tidal flexing probably will not be able to generate such heat, maintain it over billions of years. The next moon out is Ganymede. Ganymede is the largest moon of the solar system. It's actually larger than the planet Mercury, although it's not quite as massive. And it's about 50% larger than Earth's moon, just to give you a feel for it. So there's Ganymede. Beautiful moon. I love, these moons are so colorful. It kind of makes me feel like we got ripped off on our moon. Our moon's very, very gray. But isn't that beautiful? And Ganymede, because Ganymede orbits Jupiter, it's a moon. If we could separate it from Jupiter, it would undoubtedly be classified as a planet. It's big enough to be classified as a planet. So there's Ganymede, pockmarked with craters. And then the last of the big four, the outermost, is Callisto. Let's see if I can click on it. There we go. And these were all discovered in the year 1610 by Galileo. Callisto is just a little smaller than Ganymede. I believe it's the third largest moon in our solar system. So there's little Callisto. And you might notice all these other lines. These are the outer moons of Jupiter. And you can see there, wow, what a mess. The inner moons of Jupiter, you click on Jupiter and center it. The inner moons of Jupiter all orbit in the same plane in very close to perfect circles, not quite. But you see they're all in the same plane, and they all orbit in the same direction. There they are. The outer moons, they kind of do what they want because there's a lot more space available, and therefore their orbits are perfectly elliptical, just like any other. It's just that they look like they're all crossing each other. It looks very crowded, but we're millions of miles out in space now, so there's a lot of empty space. The chances of collision are basically zero, and we'll find that's a common feature of the solar system. Inner moons orbit in nearly circles in the same plane in the same direction. Outer moons, a lot of them orbit backwards. We call that retrograde motion. And they're not all in the same plane. They orbit in different planes. That's a design feature. The organization of the inner moons keeps them from colliding. You don't need that for the outer moons because they are there's a lot more space available. Okay, let me just try restarting that script and see if we can get it to work this time. Okay, there we go. Next planet out is Saturn. It's also like Jupiter. It's a ball of gas held together by its own gravity. But of course, the wonderful thing about Saturn is that it has that delightful ring system. The rings are basically trillions of tiny little moonlets that orbit around Saturn's equator. And that's wonderful. All the big planets, Jupiter, Saturn, Uranus, and Neptune, all four of them have rings, but only Saturn's are thick enough. There's so many of them that we can see them from Earth. And you can see these in even a very modest telescope, and they're just fun to look at. And as Saturn orbits the sun, we see the rings from different perspectives. And the wonderful thing, God tilted Saturn, I think it's about 28 degrees. And he did that, I think, so we could see the rings. Because you see, if Saturn had formed from a collapsing nebula, as the secularists believe, it shouldn't be tilted. And if it weren't tilted, we wouldn't see the rings. Because you can't, they're so thin, even though they stretch hundreds of thousands of miles across, they're less than a mile thick. And so when they're edge on, you can't see them. Now, fortunately, Saturn is tilted so we can see them. But because Saturn orbits the sun, twice every orbit, its rings appear edge on from our perspective, and we see a ringless Saturn. That happened 2024, I believe, in March. They went edge on. And so that happens about every 15 years, and you see a ringless Saturn for a few weeks. Saturn has a magnetic field, very strong, and that's an indication that it can't be billions of years old because magnetic fields decay over time. Secularists have proposed a dynamo to recharge them. I'll talk more about that in a little bit. There's a famous picture of Saturn taken by Voyager, I think it's Voyager 2, or maybe one of the Pioneer spacecraft. Saturn from behind. It's a crescent Saturn. And I don't know if people realize the significance of that. The only way you can see that is to send a spacecraft out there to do it. We never see Saturn like this from Earth because you have to be farther away from the sun than Saturn to see it in a crescent phase. So it's kind of proof that, yes, we really have sent spacecraft out into space, and it's wonderful. Saturn has a number of interesting moons. Let's see if they work this time. One of the inner ones that I always like to talk about is Mimas. Mimas is a little moon that orbits around Saturn. And there's an enormous crater on one side. Let me see if I can rotate it around here. There it is. I hope you can see that. This isn't the best simulation of it, but there's a massive crater on one side, about a third the size of the moon. And from certain angles, it makes it look kind of like the Death Star from the Star Wars movies. So I find that very amusing. So there's little Mimas. Bunch of moons around Saturn. Saturn currently has 293 moons, but most of them are very small. Only a few of them get big, and we're going to look at one or two of them here. We already looked at Mimas. I want to show you Titan. Titan is Saturn's largest moon, and it is orange. It is the only orange moon that we know of because it has a thick atmosphere, and that's also unique. No other moon has a thick atmosphere, at least in our solar system. So there's Titan. It's the second largest moon. For a number of years, they thought it was the largest moon, hence the name Titan, but the atmosphere is actually puffing it up and making it look a little bigger than it really is, kind of like a cat when they get upset. So there you go. If we remove the atmosphere, which we can do now because the Cassini spacecraft orbited Saturn and used radar to penetrate to the surface. So here's what the surface of Titan looks like. Really interesting surface. And one of the things that was interesting is it has lakes of liquid methane. Methane is a hydrocarbon, kind of like gasoline's a hydrocarbon. And on Titan, hydrocarbons work kind of like water does on the Earth. We have a water cycle, rains and lakes of water. Titan has an atmosphere that contains methane, and it rains methane and forms lakes of methane. One of the things that's interesting about that is methane is naturally destroyed by ultraviolet light from the sun. And so if Titan were really billions of years old, the methane should be gone. It should have converted to other hydrocarbons, but it's still there. And so secularists have proposed that there must be a source of new methane, but no such source has been discovered. On Earth, life produces methane, but as far as we know, there's no life on Titan, although that's been proposed by secularists. So that's Titan, the second largest moon in the solar system, the largest moon of Saturn. One other moon that I think is really interesting, and I like looking for it in a telescope, is called Iapetus. Iapetus orbits a bit further out, but not real far out. And the neat thing about it is when it was discovered on the right side of Saturn, and then it disappeared. And then again, you could see it on the right side of Saturn, and it disappeared. Astronomers couldn't see it when it was on the left side of Saturn. Eventually, they did, but it was much fainter when it was on the left side of Saturn and difficult to see. And the reason is Iapetus has a side, a hemisphere that is dark as charcoal, and another side that is as white as snow. And so when it's on the right side of Saturn, you're seeing the snow side of Iapetus, makes it easy to see, nice and bright. And when it's on the left side of Saturn, you're seeing the leading hemisphere, which is dark as soot. Very interesting. And we think we know why that happens. We think it's because there's some debris that's being cast off from an outer moon called Phoebe, and we think that impacts the leading hemisphere, and that's what causes that soot to build up. But really a lovely little moon. Also has a mountain range right along the equator, which is really fascinating. So it's just wonderful the details that the Lord has built into his solar system, ultimately for his glory, but perhaps for us to enjoy and discover as well. So that's the Saturn system. Now, a wonderful thing happened in the 1980s. The outer planets, Jupiter, Saturn, Uranus, and Neptune, lined up in a beautiful arc that allowed us to send one spacecraft past all four because it used the gravity of Jupiter to slingshot it onto Saturn, to slingshot it onto Uranus, to slingshot it onto Neptune. So Voyager 2 was able to go past all four of the outer planets, and it did that in the 1980s. So here's the way they were lined up in 1986. You see Saturn, Uranus, and Neptune lined up, and Voyager 2 flew past the planet Uranus, which looks like this rather featureless blue sphere. It's a gas giant or perhaps an ice giant. Like Jupiter, it might have a slushy kind of ice as you go further in, but it's not, we don't think it's solid. We think it'd be sort of liquid and slushy. And then that blue is caused by methane, which again is something that's destroyed by ultraviolet light, but that's what gives it that beautiful blue color. It's Rayleigh scattering. It's the same phenomena that makes our Earth sky blue, although it's a different different compound that's doing it. Now, the interesting thing about Uranus is it's tilted on its side. So it rotates, it rolls around the sun, which is interesting because that should not happen if all the planets formed from a collapsing cloud, as secularists believe. So like Venus, which rotates backwards, this one rotates on its side in defiance of secular expectations, but fully consistent with the creativity of a God who has built in some interesting things in his universe. Uranus has a number of moons in the 20s, I believe, and most of them were discovered fairly recently. When I was a kid, it had 5 moons, and these are the 5 that you can see with a modest backyard telescope and really good eyes. They are Miranda, Ariel, Umbriel, Titania, and Oberon. Let's just go to Miranda, the innermost of the big 5, and the only one I've not been able to see in my telescope. The other 4 I can see, although they're very, very faint. So here's Miranda. Really interesting surface. And because Uranus rotates on its side, so does Miranda. And so it orbits around Uranus's equator, which is what inner moons tend to do. And so, like the other planets, the inner moons all orbit in the same plane and in the same direction. You can see that there. It's very organized. Let me go out a little bit. There you go. You can see how they all orbit in the same plane in the same direction. If I speed up time, you can see that, including the big 5. And then there's a bunch that Voyager 2 discovered that orbit even closer. And then the outer moons kind of do what they want. That's a common feature of the solar system. I would argue it's a design feature. It's something we would expect so that these moons don't collide with each other. So the planet Uranus. And Uranus has a very strong magnetic field that is not aligned with its rotation axis. And that's something that was predicted by the creation physicist Russ Humphreys back in, I think it was 1984. He predicted the magnetic field of Uranus based on its biblical age of 6,000 years. The secularists thought that Uranus would be magnetically dead, and they were dead wrong because they didn't start with the Bible. You want to get the right answer, start with the Bible. But the fact that Uranus's magnetic field is not aligned with its rotation axis, it's not even close, that is something that really can't be explained by the dynamo models, which is the mechanism that secularists use to try and recharge the magnetic field so it can last billions of years. And that's just an indication that that model isn't correct. Well, in 1989, Voyager 2 flew past Neptune, kind of the little big brother of Uranus. Neptune is smaller than Uranus, but more massive. So Neptune would be the fourth largest planet, but the third most massive in our solar system. And one of the things that Voyager 2 discovered is that Neptune has a great storm on it, just like Jupiter's red spot, although this is a low pressure system, so it rotates the other way. It's like a traditional hurricane. So there you go. And it's quite beautiful. I love Neptune. I just love the colors on it. Very beautiful. And there's these white cirrus clouds that you can see in its atmosphere as well. So very, very pretty. Neptune has a strong magnetic field that was also predicted by Russ Humphreys back in 1984. And Voyager 2 confirmed his prediction in 1989. So again, if you want to get the right answer, start with the Bible. That's going to at least give you the right data to begin your hypothesizing. So there's Neptune, has a number of moons. Only one of them is big, and it's not even as big as Earth's moon. It's about 78% the size of Earth's moon. But it's very interesting. It's the moon Triton, not to be confused with Titan. Titan orbits Saturn. Triton orbits Neptune. And here it is. There's Triton. We got some wonderful images of it from Voyager 2. Now, you'll notice this side is a little bit blurry. That's because Voyager 2 was far away from the moon when it took pictures of this side. And then as we rotated around, Voyager got closer as the moon was rotating. And so we got some really wonderful images of this side. And one of the things that was fascinating are these black streaks that you see on its surface. They're actually caused by geysers, nitrogen geysers that spew soot up into Triton's very thin atmosphere. And the prevailing winds then deposit those streaks in an east-west fashion. Really amazing. And one of the things that indicates, if you got geysers, you have to have internal heat. You have to have a warm interior that's powering those geysers. And Triton's smaller than the moon, so it can't maintain heat over billions of years. And so this is an indication that this little moon is not billions of years old. It's consistent with the biblical time scale. The other thing that's interesting about Triton, let me back out a little bit, go back to Neptune. Triton orbits Neptune backwards. It's the only large moon that orbits backwards. Let me see if I can show you this. Center it. There we go. Where's the orbits? There's the moons. Speed up time. The inner moons are doing what they're supposed to. They're orbiting the correct way, and Triton goes just backwards, just the opposite of the way that it was supposed to be doing according to the secular time scale. So according to the secular predictions anyway. Now, Pluto, when I was a kid, Pluto was a planet. But as we started finding objects that are nearly as large as Pluto, we decided we either needed to add another 5 to 10 planets to the solar system or get rid of one. And for the record, I think they made the right call. Let's see. There we go. We had to wait on Pluto. When I was a kid, we had no good images of it because the Voyager 2 couldn't go past Pluto because it wasn't part of that arc. And so we had to wait until the year 2015. In fact, let me rerun that script. I want to make sure I get the right. Because Pluto's moved a little bit since 2015. But in 2006, we launched a spacecraft called New Horizons. Fast as we could get it there. It took 9 years to get to Pluto because it's over 3 billion miles away, and got these wonderful images. Pluto is very, very interesting. Secularists were expecting this little dwarf planet would be completely covered with craters because it's only 2/3 the size of Earth's moon, so it can't have any internal heat. Any internal heat it started with after 4.5 billion years would be gone, long gone. And then also, because there's lots of other objects out at about the same distance as Pluto, over 4.5 billion years, everything ought to have hit it, and so it should be completely covered with craters, but it's not. It does have some craters. In 6,000 years, some things have hit it, but there are some places that have no craters, like this large region right here, Sputnik Planitia. There's no craters there. And in fact, there's this tessellation pattern. I hope you can see that on the projector there. And we think that's a convection pattern, which indicates that that was once sort of like magma, although a much lower temperature sort of magma, and frozen, and is now frozen in. That indicates that Pluto once had internal heat. It might not anymore, but in 6,000 years it's lost it. But over billions of years, that should be all covered with craters by now. But it's not. It has a very youthful surface, and even the secularists were amazed at how youthful the surface of Pluto is. It also has mountains. Those look like little bumps, but keep in mind we're looking at something 2/3 the size of Earth's moon. Those are mountains made of ice. Ice is as hard as rock on Pluto, covered with a thin layer of tholins, which is a byproduct of methane. There's still a lot of methane on Pluto. So really astonishing. And then Pluto has a large moon, actually has 5 moons, but only one of them is big, and it's called Charon, about half the size of Pluto. And likewise, Charon, it's not just completely covered with craters. It has a few, but it also has mountains and valleys. It also has a youthful surface consistent with its biblical age of about 6,000 years. Very interesting. Has a dark north pole, which we've never seen before. We're still not sure exactly what causes that. There's still a lot of mysteries out there, and that's wonderful. Science is about discovering these sort of Easter eggs that the Lord has hidden for us in his universe. So I'm really grateful for the New Horizons mission. It cost a lot of money, but I'm grateful that we have these images of this little dwarf world, which is what it's now classified as, a dwarf planet, along with a few others. But really lovely. Pluto was discovered in 1930 by Clyde Tombaugh and had a planet status for over 70 years. So it was kind of heartbreaking to a lot of us to have it demoted, but there it is. And I kind of want to end this by going back to Earth, because of all these planets, this is the one that God designed to be inhabited. Isaiah 45:18 says that God formed the earth to be inhabited. It's designed for life. It has a special beauty to it because there's life covering its surface. The green that you see there is caused by the various plants that the Lord created and the chlorophyll within them that converts sunlight into sugars, which we use. And of course, Earth being at the right distance from the sun, Earth having the right tilt, so on and so forth. Really amazing. And I love the fact that, again, we've had astronauts that have seen it from space and have sent back these glorious pictures of the Earth from space. Really beautiful. But this is the planet that God created and died on. This is the planet where God himself, God the Son, became a human being. He retained his divine nature, but he's human as well. And so that he could die. That was the purpose of Christ coming to this planet. Jim Irwin was one of the astronauts who walked on the moon, and he later became a Christian. As you might imagine, that would be an inspiring experience. But a very devout Christian. He went on searches for Noah's Ark and so on. And there's a quote, and I'm going to paraphrase it, but basically he said something like this: "The amazing thing is not that man walked on the moon, but that God walked on the earth." This is the planet that has the footprints of God on it. This is the planet where God died our death so that we could live forever with him if we just repent of our sin and trust in his saving grace. And I do want to show you here a few of the resources that we have. This presentation called Worlds of Creation, of course, I never do it exactly the same. I'm actually kind of pontificating. I never do it exactly the same way twice, but a lot of this information you can get on DVD, and we have that on our website, so you might want to check that out. Astronomy Reveals Creation is another DVD that covers a lot of the stuff that goes beyond the solar system. Created Cosmos is the planetarium show I wrote for the Creation Museum. I'm real proud of it. It turned out really well. It takes you on a tour of the universe from a biblical perspective. And his star, what about the star that guided the Magi to Christ? So we have some wonderful DVDs. You can get these on our website, as well as books. Taking Back Astronomy shows that the universe really is God's. It's God's creation. It's not the result of a big bang or billions of years. Stargazer's Guide to the Night Sky. If you want to learn how to find these objects in the sky with a small telescope, you can see Jupiter. You can see Saturn. You can even see Saturn in binoculars. You just got to know which one's Saturn. It's a naked eye object. You just got to know which one it is. It'll show you the constellations, tell you when the next meteor shower is happening. By the way, next meteor shower, August 12th. It's coming up next week. But it'll show you, if you want to get a telescope, how to use it. what kind you might want to get, and so on. But a lot of stuff you can see naked eye or binoculars. The physics of Einstein, if you've wondered about how did God get the light from those distant galaxies to Earth in the biblical timescale, it's covered in that book, along with a lot of interesting things like time travel, black holes, and such. And we have a brand new book written by our illustrator, Dan Lisle. Now, this is designed for youngsters, junior high. I think maybe even older elementary school students would enjoy it. And frankly, there's a lot of adults that would enjoy it as well. You'll learn something from this book. You read it and then you give it to your kids, and I think they'll really like it. It really is masterful. It's a discussion of this, and we need to know something about this topic because alien life is a hot topic. You know, the Disclosure Day, a lot of the movies that come out involve alien life. Other books as well, The Importance of Genesis, Why Genesis Matters, Why the 6 Days is Important, and then Understanding Genesis, how to defend the literal historical reading of Genesis, which is how Moses intended it to be read. And we can know that, and that book's going to equip you to defend that. The Ultimate Proof of Creation, giving a bulletproof argument for biblical creation. A lot of people have said this book really, really helped them to be able to defend the faith well. And you can get all of these on our website, biblicalscienceinstitute.com. So there's our QR code. You can check that out. And I think I'll end there, and happy to answer questions if you have any. And thank you very much, by the way.
Wow. Yes. Well, thank you, Dr. Lisle. And I imagine we will have some questions, so we'll bring you a microphone. Dan.
You said that you'd either have to take away one planet or add 4 or 5 more. I thought that was kind of interesting. And then, are they farther out than Pluto? Are they kind of interspersed in between, or?
Yeah, most of them are farther out than Pluto. The one that really forced the decision is much further out than Pluto. It's called Eris. And it's at the time it was discovered, they thought it might even be bigger than Pluto. Most of them are just a little bit beyond Pluto. There's Makemake, there's Haumea, Eris. There was some discussion, should we add Ceres, the largest asteroid? And all of those are now classified as dwarf planets. So, but yeah, all of them except Ceres are out farther than Pluto. There are a lot of objects that are in the same orbit as Pluto, called Plutinos. They have the same orbital period as Pluto, 248 years. So they share Pluto's orbit in sort of probably Trojan positions, but none of those were large enough to be added to the categories. Probably only 4 or 5 more they'd have to add. Not the first time that happened. When the first asteroids were discovered, they were classified as planets. And then once we got up to like 16, they're like, this is ridiculous. We need to these are all small. We need to classify them as a new type of object.
Any others? Matt.
What do you think of the hydroplate theory and ejecting materials up into space, and that is the genesis of some of what the comets and things that we see in our planetary system?
Yeah, I would say no definitely no for the comets. Danny Faulkner did a nice article on that. If comets had been the result, if they had been ejected from Earth, then we could trace their orbits back to Earth. Now, there are other things that can change their orbits, but we know about those, and we can work the math backwards, and we would find that they would all go back to Earth on the flood years. So I would say definitely no for the comets. I'm not anti-hydroplate theory. It's an interesting idea. I currently favor John Baumgartner's model. I like it better personally, but it's nice that we have different models out there. But I would say no for the comets for sure.
Hello, I just wanted to thank you for all your work, and I have one question. How far away is the furthest star?
Oh, well, we keep finding stars that are farther and farther away. In terms of individual stars, I mean, we find galaxies. The farthest away stars are in galaxies that are so far away we can't resolve the individual stars, but presumably they're there. And they're so far away that rather than using traditional units of distance like miles or even light years, we use what are called redshifts, and that shows how much the light has been stretched. And the farthest galaxy that we're confident, and therefore the farthest stars that we're confident we've detected, are at a redshift that's greater than 14, which would be billions of light years away, very, very far away. And there's some we think that are a redshift of 20, but those haven't been confirmed yet. So, and these have been discovered recently by the James Webb Space Telescope. The farthest galaxies we know have been discovered by the James Webb Space Telescope.
I had a question. I've heard your presentation on fractals, and I heard a speaker talk about how the Grand Canyon actually, when you look at it, is a fractal. And so the question that came up, well, how did it form as a fractal? And their determination was, at one time when Mars had a different elliptical pattern, that there was a confluence of Earth and Mars on a continuous basis. And at one time, there was a closeness where the electromagnetic discharge between the two actually caused the fractal on the Grand Canyon, on Earth, and then the formation of the Valles Marineris on Mars. As supposedly this was documented by, some of the literature in the past, like Gulliver's Travels and Gilgamesh and some of those, that they actually saw that these Mars and its two moons, so it must have been historically true for people to see those Mars planets. Comments on that?
Yeah, it sounds a little bit like the Velikovsky hypothesis. I would say there's no good evidence that Mars's orbit was any different from what it is now, at least not substantially. And there's good evidence against that. It's really hard to change the orbit of a planet, unless you want to say that God did something supernatural. God can do what he wants, but there's no observational evidence for that. Grand Canyon is likely the aftermath of the flood, either directly from the flood or perhaps a post-flood, a dam collapse of a post-flood dam that broke and then formed the Grand Canyon. One of those two. The layers of the Grand Canyon are flood layers. We find fossils in them that are associated with the flood. So it's a flood or post-flood phenomenon. And then there's good evidence that Mars has always had the orbit. We have records of Mars going back to ancient times, and its orbit is consistent with what we would expect based on current parameters. It is true that Gulliver's Travels anticipated that Mars had two moons. It was commonly thought since Jupiter in 1610, Galileo discovered that Jupiter had four moons, Earth had one. And so a lot of people reasoned that Mars would have two because that's the geometric mean between 1 and 4. And so a lot of people speculated that Mars would have two moons, and it turns out it does, but for the wrong reason, because we now know that Jupiter doesn't just have 4 moons, it has 115. So it turned out to be true by accident. Also, Gulliver's Travels, they really weren't quite right, because they said one moon orbits retrograde and the other prograde. They don't. They're both prograde. It is true that one from the surface would appear to rise in the west because it orbits faster, but they're both prograde. So they didn't get the details right. So it's just an interesting coincidence that they guessed two moons, as a lot of people did.
You've indicated in your talk that if to have a planet to have a strong magnetic field or heat, they can't be millions of years old.
Yeah.
And Peter tells us that someday that these elements will melt with fervent heat and we'll have a new creation and new heavens and a new earth. So if we're spending eternity with God the Father, and what will be the new heavens or the universe or the earth if they do decay like they do now? Will they not decay then, do you think?
Yeah, I presume that in the new heaven, well, the Bible indicates the new heavens and new earth will be eternal. They're going to last forever. And that doesn't mean that no decay can happen, but it does mean that if there is a decay, there also has to be some kind of restoration. There might be a decay process like entropy, even in the eternal state, but it might be balanced by a reorganizing phenomena. That's my best guess. The Bible, of course, doesn't give us a lot of information on the eternal state, but I'm guessing that's the case because that was probably the case originally before sin entered the world. Theoretically, I mean, Adam and Eve would have lived forever if they had obeyed God rather than disobeyed. And so, how do we account for that? Isn't the sun eventually going to run out of energy? Well, before sin, there must have been a restoring force, and I presume that God will do something like that in the eternal state, but we really don't know. The only thing we know for sure is that it will be eternal because that's something the Bible promises.
Hello, Dr. Lisle. Is the
Hi.
microphone on? Okay. I may get some snickering from my question, but I'm going to answer or ask the question anyway. But as a Christian, Bible-believing scientist, are you open to the Holy Spirit to guide you to the possibility that for centuries and through various scientific experiments, and the fact that you alluded to, the fact that Jesus walked on this earth and he was born on this earth and he redeemed us on this earth. And so the earth is a very special place, as you pointed out. So I guess getting to my question, are you open-minded? Are you totally dead set against the geocentric model versus a heliocentric current model? Are you willing to allow the Holy Spirit to guide your heart through Scripture and to maybe having an open mind towards a possible geocentric model that they taught for hundreds of years?
Well, the geocentric model, as it was proposed, around the time, in the 1600s and so on, is not something you could get from Scripture. And I don't believe you could get heliocentrism from Scripture either. I believe the Bible's silent on that issue. It speaks to the roundness of Earth. It does give us a few details about space, but I don't believe it speaks to that issue. Some people have misinterpreted passages like Psalm 93, where the Earth shall not be moved, and what they're doing is they're saying, well, moved means in a Newtonian sense, that it doesn't orbit the sun in terms of Newtonian physics, but that the sun goes around the Earth in sense of Newtonian physics. But Newtonian physics hadn't been thought of at that point. So to use the word that way is what's called a semantic anachronism fallacy. And the Hebrew word for moved is mot, and it means to slip, fall, or be out of chorus. It's the same word that the psalmist uses when he says, I shall not be moved. He doesn't mean he's going to be stationary his whole life physically. He means he's not going to deviate from the path that God created for him. And so that's what the passage means biblically. If we're going to allow the Bible to speak for itself, then the passage indicates that the earth will not deviate from the path that God created for it. And that's all. It doesn't tell us what that path is. It doesn't tell us that the sun goes around the earth, that the earth goes around the sun in a Newtonian sense. We do, of course, the Bible does use phenomenological language, sunrise and sunset. I do too. When I say, oh, it's a beautiful sunset, I don't say, oh, look how the Earth's horizon has reached a point where the plane, the sun is below that plane now. I mean, we use that kind of language all the time because it's convenient to do so. You can talk about the Earth as a reference point and say things move relative to the Earth. That's fine, but you can do that for anything. You can do that for Mars. You can do it for the sun. I can do it for me. I can say I'm the origin and everything moves relative to me. But in a Newtonian sense, the Earth goes around the sun. And the Bible's not talking about Newtonian physics because that terminology had not been discovered yet. That was discovered really in the late 1600s, early 1700s. So I hope that helps.
Thank you for being here, Dr. Lisle. Just been following you for many years, and I'm so grateful that you were able to meet with us. I'm confused a little bit about other planetary volcanoes. When you say volcanoes, and I'm guessing that they explode, but to have explosions, you have to have enough oxygen for fire, or do they just regurgitate material?
Yeah, more the latter. They don't need oxygen. Although there's some oxygen on Mars. It's just trapped up in carbon dioxide. So the volcanoes on Mars are not so much the explosive type. The explosive type that we get on Earth are the stratovolcanoes, but what are called the shield volcanoes. Those are like the ones you get in Hawaii, where the magma just kind of flows out like that. Those are the kind that you get on, at least on Mars. And on moons like Io, the chemistry is totally different because they're not the kind of magma that occurs on Earth. They're sulfur volcanoes. So it really depends on which planet or moon you're discussing. But yeah, with Mars, they're shield volcanoes like the ones in Hawaii, where they kind of ooze out magma, but they do release, we think, water vapor, and that might temporarily increase the atmospheric pressure to where it could condense and form liquid water temporarily. That's Ron Samek's model, which is an interesting one.
Anybody else?
Would you have anything to say about beyond our solar system evidences for youth? For example, from the James Webb Telescope, just a way to extend out a little bit further this idea that we live in a created universe.
Yeah, I think there are. The way that spiral galaxies wrap limits their age. It doesn't limit it to thousands of years, but it limits it to much less than the 10 billion years that they're supposed to be. With James Webb Space Telescope, there probably will be some. I've predicted that the telescope will discover strong magnetic fields or evidence of them on planets, exoplanets, planets orbiting other stars. And that would be confirmation of the biblical timescale. I don't know that it's discovered those yet. And it would have to be an indirect measurement because it can't measure directly the magnetic field of something like that. But there could be indirect evidence of strong magnetic fields on exoplanets, planets that orbit other stars. So we'll wait and see. But I'm expecting that will happen. And we already do have evidence beyond our solar system of a young universe, such as spiral galaxies or blue stars, which can't last billions of years. And as far as we know, that new ones don't form. That's the secular idea, is that new blue stars are constantly forming. We've never seen that happen. And the physics there suggests that it might not even be possible.
I do not see any Calvin and Hobbes on your bookshelf behind you, but I was just kind of curious, what do you do for enjoyment, for reading, and what's the next book you're working on right now?
Oh, okay. For enjoyment, I like to hike. I live in Colorado. It's a beautiful state. I like to get out and hike, photograph, birds and things like that. That's a lot of fun. A lot of what I enjoy is kind of what I do. I like observing stuff through a telescope and showing that to other people. So those are some of my hobbies. And then with regard to books, I just finished one on God's law, and that's now available on our website. And even though that's a little bit off topic from creation, it's something that a lot of people have questions about. And critics try to get us on that because they'll say, well, see, you don't obey all God's laws because you eat shrimp and bacon, and the Old Testament says you can't do that. So it discusses, the ceremonial laws and things like that, and it enables you to be able to defend that against a critic who accuses you of being inconsistent. And then the book that I'm working on now, which I'm really excited about, is a book on how we got the Bible. And this is something that I've had an interest in for a very long time, but I haven't written too much on it. But what it'll do is it'll go through some of the manuscript evidence. I want to show people some of these ancient manuscripts and how they confirm that what you hold in your hand today really is the Word of God. But I don't want to sidestep the fact that, yes, there are minor copying mistakes, and we know what they are, which means we can correct them. And how that kind of thing is discovered. So it should give people confidence that the Bible that you hold in your hand really is the Word of God and you can trust it. Really excited about that one.
Anybody else? All right. Well, then thank you, Dr. Lisle.
Thank you.
Very interesting. Excellent. Well, one last announcement. How many of you saw the film A Great Awakening that was in town a few weeks or months ago? Good. Well, it's going to be shown here on Sunday, August 9th at 6 p.m. So if you want to see it again, or if you want to send friends who haven't seen it, it's going to be shown here this Sunday. Well, thank you all for coming. And the next forum will be November 3rd. And we'll have posters for that when the time comes.